let's talk a little bit more about the Pythagoras today and the Pythagorean theorem. The idea that the sum of the squares on the legs of a right triangle equals the square of the hypotenuse. So we know that to be true. I'm wondering if that works for other shapes. Let me show you what I mean. Let's see if it would work for triangles. So what if I put a triangle on this leg and a triangle on this leg and a triangle here? Well, it certainly looks like it works, but we haven't proven it yet, have we? We haven't proven that these two added together equals that triangle there. So let's think about what we can do. We have to do some remembering about some of our equivalencies. I remember that these two triangles equal these two, right? Yep. These two rhombuses are equivalent when each of these triangles is half. So that means one of these equilateral triangles equals one of these obtuse-angled triangles. Okay, that's going to help us as we work to solve this. Okay, so I can see that I have one of these equilateral triangles here on this side. And let's just take a look here. This triangle equals 3 of the obtuse-angled ones that are equivalent to this. So that's 3 of those. And what do we know about this large triangle? We know that it should equal, let's just make sure that it equals 4 equilateral triangles. So let's go back and think about this equivalence. If this is 1 and this is 3, and this equals 4. Oh, Pythagoras works for triangles built off of a right-angled triangle. Well, if it works for triangles, do you suppose that it will work for rhombuses? Let's see. I'm going to build a rhombus here. And there's a rhombus. And okay, so I've got a rhombus of 2 here. A rhombus of how many? 1, 2, 3, 4, 5, 6 here. So 2 plus 6 should equal, how many are there here in this rhombus? 4, 5, 6, 7, 8. 2 plus 6 equals 8. The Pythagorean theorem works for rhombuses. The sum of the rhombuses built on the legs of this triangle, right triangle, equal the rhombus built on the hypotenuse. Well, let's not stop there. I wonder if it works for trapezoids. All right, let's try it with trapezoids. So let's put, here's a trapezoid. I've got a trapezoid on this leg. And I just need a trapezoid on this leg. Okay, so now we're checking to see if the sum of this trapezoid plus this trapezoid equals this trapezoid built on the hypotenuse. So we've got a trapezoid of 3 here. We have a trapezoid of 3, 6, 9. So 3 plus 9. And that means this should be 12. And we have, in fact, 4, 8, 12. 3 plus 9 equals 12. So the sum of the trapezoid built on the legs of a right angled triangle equals the trapezoid built on the hypotenuse. We trapezoided this triangle. But let's not stop there. Let's see if we can keep building. So let's see if we could build a hexagon. I cut some extra triangles to help us with this one here. There we've got a hexagon. And let's build over here and see if we can also build a hexagon. Whew. I have a hexagon here off this leg, another hexagon here off this leg, and a hexagon off of the hypotenuse. So let's see if it works. We have a hexagon here with a value of 6. Here it's going to be 3, 6, 9, 12, 15, 18. So we're going to have 6 plus 18, which is 24. Here we know this has a value of 4. So each of these big triangles, 4, 8, 12, 16, 20, 24. So it's true. When we build a hexagon off the legs of a right-angled triangle, the sum of those hexagons equals the hexagon built on the hypotenuse. The Pythagorean theorem works for other shapes besides squares.